Hello everyone, I'm Karthik from ITS section and my roll number is 20951230. And today I'm going to discuss about the interactive web applications in web application development. So on Tech Talk, my topic is about beyond first impressions, estimating the quality of experience for interactive web applications. So let us know what are these interactive web applications and their quality of experience for web applications through their first impressions. Let us dive into our topic. So coming to the abstract, here the number of web applications for both personal and business use will continue to increase. The popularity of web applications has grown, increasing the need to estimate quality of experience for web applications. Web QoE helps providers to understand how their end users perceive quality and point towards areas to improve. Waiting time has been proven to have a significant influence on user satisfaction. Most studies in the field of web QoE have focused on modeling web QoE for the user's first interaction with the application. For example, the waiting time for the first page load to complete. This does not include a user's subsequent interactions with the application. Users keep interacting with the application beyond the first page load, resulting in an experience that consists of a series of waiting times. In these interactions across a web browsing session and to measure the correlation between the waiting time and the user reported perceived quality, we provide a short survey of existing web QoE estimation metrics and models. We then propose two new measures, interactive load time and a total completed interactive load, to establish the waiting time associated with the web application user's interaction. So coming to the introduction, web-based application performance relies heavily on a quality of service metrics for optimized network parameters. These optimization techniques do not consider human factors, and parameter adjustments may not result in a perceptible quality improvements from a user's perspective. So quality of experience considers a user's experience factors beyond the service. That is, context, user, content, and system factors. QoE provides further insights into the user's quality perception and their satisfaction. The relation between the QoE and the QoS allows us to understand how to improve the end-to-end performance with respect to the user satisfaction. So this is the figure one. So it tells the illustration of quality of experience influence factors. So considering a QoE of web application systems and services factors including the network and the computational components. Here the influence factors are system, service, content, context, and the user, and the quality of experience is the user. So here the computational components and the content refers to the how the information is presented, that is the media type or the resolution or the content length. So the context covers the subject and the theme of the content. So that is the business and the leisure and educational. So finally the user covers the user experience and the expectations from the web application. This is the idea of the figure one. So web application quality can be measured at a different levels. So network application, client, and end user. Expect for the end user level objective quality matrices can be deployed to monitor QoS. Estimating end user perceived quality requires subjective experiments which are expensive and time consuming. In order to include the end user satisfaction in object metrics, the researchers have been working to develop mapping functions between the QoS based objective metrics and the subject QoE experimental. These mapping functions can be help identifying the interdependence and between the factors such as a network and application factor. Let us take an example like a mapping function between a network and a QoS metric and an application performance indicator, that is also known as KPI, or the application KPIs to experimental findings of subjective perceived quality. The mapping between the matrices facilitates the development of object metrics and the models that explain the perceived quality and with a lower cost and the overhead. So this is figure 2. Here the influence factors are web application servers, the network, and the client and the end user. So we consider the quality measurement for each influence factors. Let us take up the web application server, the application level objective quality matrices. Example, the API execution time. For the network, the measurable QoS parameters are examples, delay jitter and loss throughput. For the client side metrics such as examples are page load time and time to first byte. So coming to the end user, the QoE metrics based on the subjective studies examples mean opinion score. So illustration of the quality measurement in the context of a web QoE, the mapping between quality metrics can help to understand the interdependence between the factor. So coming to the related works, quality metrics and the models are the key components of a web QoE analysis. Quality metrics are used to measure the efficiency and the performance of the web applications. QoE models utilize objective quality metrics to estimate the perceived quality of the end users. Perceived quality is widely measured in the domain of a QoEs using subjective user ratings where the subject rates quality on 5-point absolute category rating scale. They are bad, poor, fair, good, and excellent. Using the results from a group of test subjects, a mean opinion score is expressed as a single rational number, so computed as the arithmetic mean of the subjective ratings. Researchers utilize the different variations of waiting time metrics for web QoE analysis. In this section, we explore the time metrics available to measure waiting time for the web applications. So coming to the figure 3, here the illustration of the quality measurement metrics. The majority of the objective quality metrics are defined based on the first page load. However, the web users interactions continue to happen past the PLT. Here, this diagram, it contains the network and the web application server. The communication is between the network and the web application. It is from a request to the response. Web evolution and QoE challenges. Over the years, web applications have been transitioning from traditional models, which use static pages, to dynamic user interfaces with real-time and collaborative features. It is now common for web applications to link or embed information from other web applications such as social media or open data platforms. This contrasts with the traditional web model that is based on the multi-page interface where every request results in a full page refresh. Ajax and Comet programming are now commonly used in the development of interactive web applications. These techniques eliminate the page-by-page navigation limitations of the traditional web model. A single page Comet and Ajax applications loads the data displays page components independently. So coming to the figure 5 illustration of ILT measurement based on the user's interaction and the web events. ILT is measured by computing the duration between the starting time of the first event until the ending time of the second event. Web mapping applications are an example of applications using Ajax. Example: Google Maps has been integrated into geographic information system applications using Ajax. The interactive nature of a web paging applications requires a user request to be quickly actioned in order to maintain relevance, flow experience, and user attention. Using Ajax allows web maps to load progressively, and each time a user re-enters the map. Some maps images are kept for display while new tiles are fetched to update the viewing view using a XML HTTP request. Motivation: a growing body of literature has investigated modeling web QoE using time, instant, and integral metrics. The models generally utilize the first page load metrics. However, there has been little quantitative analysis on measuring waiting time caused by the user's subsequent interactions and its impact on the user's QoE. As we explained in the previous section, the critical aspects of our motivations can be summarized as follows. When a user navigates a web application, the initial page load occurs. Then the user starts interacting with the page elements. The duration of interactions is proven to be a significant part of the total web browsing session time. Thus, the user interactions needs to be considered in the perceived quality estimation. Interactive web application is use technologies such as Ajax, WebStocks, WebSockets, and HTTP2. The user's interaction causes a waiting time that does not reload the entire page and is proportional to main PLT or ATF. The interactive waiting time can be caused due to the numerous reasons. An XHR transaction in Ajax web applications, HTTP to push messages, 3 a client side navigation process. SI and PSI metrics do not include a browsing event. Instead, they are looking at how fast the ATF of the page gets painted to the browser. In an interactive web application, the user interactions does not reload the entire page. So this is the figure 6, the experimental platform developed for the user study. The platform simulated a real network environment and consisted of two node servers and a client machine. The network is dynamically manipulated to increase the ILD. User behavior and waiting time and perceived quality. How does user behavior change based on the waiting time, and how is it related to the perceived quality? We examine user behavior using two metrics. First, the number of clicks and that a user makes interactions with the web mapping application, and the second, the total completed interactive load to load represents two heat maps that show the relationship between the interactive load time and the perceived quality from the experiments using map and the satellite trials respectively. The color ranges are from a white to dark blue, indicating an increase in the user activity based on the number of clicks. So coming to the limitations, in these experiments, users rated session QoE for a series of ILTs. The influence of memory effects on the perceived quality was not explored. Are some ILT in the series more important to the rated QoE? The current study is taken driven QoE study where the type of a task and content could be silent factors in the influencing web QoE. Our choice of client-side metrics have been shown to effective in measuring the user experience or waiting time for a session, but is challenging to implement the measure them as a monitoring tool in the wild. Lastly, we have used a web mapping application use case and representative of an interactive application that requires a smooth flow experience to develop the metrics and the model. Coming to the conclusions, we reviewed the existing models and the metrics used for web QoE estimation, that is time instant and the time integral. metrics. Existing metrics are based on the first page load occurrence. We discussed why these current metrics are not sufficient to measure the perceived quality for the interactive web applications. We explained that the user keeps interacting with the applications after the first page of load, rendering PLD inadequate for the interactive web applications. We introduced the ILD and TCIL, which capture the waiting time associated with the user interaction. The ILD and the TCIL metrics are computationally simple, and both metrics can be continuously measured by Beyond and PLD and ATF completion times. This is about the Beyond first impressions for the experience and the quality for the web application. Thank you.